Still on JAM question 2001. Question number 8. The efficiency of a machine is always less than 100% because A. The work output is always greater than input. B. The load lifted is always greater than the effort applied. C. Effort applied is always greater than the load lifted. D. Velocity ratio is always greater than the mechanical advantage. Okay. To answer the question, we need to understand what it means that the efficiency of a machine is 100%. When we say that the efficiency of a machine is 100%, we are simply saying that the machine will give you the exact amount of what you give it. Are we together? If, let's take car as an example of a machine. If I buy petrol of 1,000 joules, I want to measure the energy in the petrol. If I buy petrol of 1,000 joules and put in my vehicle, my car, and my car gives me energy, output or energy of that same 1,000 joules, then my car is said to be 100% efficient. But no car can do this. No car can do this. Because the purpose of a car is to move. Car is developed to enable movement from one position to another position. So anytime you purchase petrol from petrol station, the car will use some of the energy to run the internal engines of the car. That's why every car must have what we call exhaust pipe. When the car is running the engine will not utilize all the energy from the petrol into useful mechanical energy. The engine of that car cannot convert all the energy in the petrol into useful mechanical energy or motion or movement. Some must be wasted through the exhaust pipe. Some will also be wasted as sound. Some will also be wasted as what? Heat. So no machine has the ability to convert its work inputs completely into work outputs. You can't give machine 1,000 joules of energy and the machine will give you back 1,000 joules of energy. No, it's impossible. So any machine that does this, that gives you that same amount that you've given it as input, as output, that machine is said to be 100% efficient. So that's the ideal condition targeted for machines, but not yet, we've not yet got to that destination. So no machine is 100% efficient. In every machine, the work input must be greater than the work output. We'll give more to collect fuel, because some of the energy given will be used in the form of other energies, will be converted to other forms of energy. Yeah, the second law of thermodynamics. In every conversion of energy, there must be some amount of useful wastes. Okay, so the question is targeted towards the efficiency of a machine. Then recall, the easiest way to answer this question is to go back to your equation. Physics equations have so many codes that will help you answer your theoretical question in the standard exams. The equations guide you to answer your theoretical questions. Recall, there are two key formulas for efficiency. Let's see. The first one is work output over work input times 100 over 1. You can see that the input is the denominator and the output is the numerator. The greater number must be the denominator. So you have a percentage less than 100. With time, you understand what I mean? Or efficiency equal to MA over VR times 100 all over 1. These are your two key formulas for finding efficiency. Okay, this is what I meant earlier. Observe the first equation. The work output and the work input. Let's assign magnitudes. Let's say I give work of 10 joules and what I will get back is 10 joules. Then notice 10 divided by 10, 1 times 100, 100%. Perfect machine, ideal machine, 100% efficiency. But this can never happen. At the work output, I'm expecting decrease because some of the energy I've given my machine will be converted to sound, heat, and so many other forms of energy, thereby causing decrease in the output. So let me say that 9 comes out at the end of the day. So 9 divided by 10, I'll be having 0.9. 0.9 times 100 will be giving me 90%. 90%. You see, no machine can go beyond 100%. Okay, now this is the ideal way of putting this equation. When you take it the other way, you'll be having 10 divided by 9. You'll be having 1 point, which will give you a value greater than 100%, which is not possible for any machine to do. Okay, so for my equation, you notice that the input is always greater, and the same thing will apply here. You have 9 here and also have what? 10. The VR will always be greater than MA. The same way the input, the work input will always be greater than the work output. Take note of that. Take note of that. In efficiency, the denominator is always greater. Okay, see what I mean? Okay, let's do the mistake of putting 10 here and putting 9 there. If 10 is here, okay, let's do the mistake of putting 10 here and 9 here. I'll be having 10 divided by 9. Give me 1.11 and you continue. Then times this by 100. You'll be having 110. Okay? We'll be having 110%. So it's not greater than 100%, which is wrong. Okay, coming to the option. From what we've said so far. Work output is always greater than work inputs. You can see the output cannot be greater than the inputs. Otherwise, that machine will be giving you more than you've given it. It's no more a machine, it's not a god. If you give a machine 100 joules and a machine gives you 150 or 110 or 102 or 103 joules, gives you more than you've given it, then that means not a machine again. That means a deity. Begin to worship it. It's not creating energy from nowhere. No machine can do that. We're even saying that no machine has got 100%, not to talk of machine creating energy from nothing. So that's what the first option is saying. Something was created from nothing. Work output is always greater than the work input. No, that's impossible. Okay, load lifted is always greater than the effort applied, and C is the opposite. Effort applied is always greater than the load lifted. So from our equation, you can see that efficiency is highly connected with work input and MAVR. Even though we can also make it to appear as load and effort. But let's focus on the equation. Then coming to the last one. Velocity ratio is always greater than the mechanical advantage. That's what we said. VR must be greater than MA. The same way work input must be greater than what? Work output. So the best option, you can see the equation is taking its basis from MA over VR, where VR must be greater than MA. So we can get something less than 100%. That is the real machine. And the question is centered on real machines that have efficiency less than 100%. Why ideal machines have efficiency 100%? Why God machines, deity machines will create energy from nothing? Create something from nothing, which is impossible. Thank you so much. Stay tuned as we continue.